basically on bank churning prediction. The problem statement was that based upon like the customer's churn rate, there was a substantial revenue leakage and a significant like loss in customer life value whenever the bank was having some uh, or do we say the bank was lacking the clear understanding on where the underlying factors such as demographic, financial, and behavioral aspect of the customers are accounting to this loss of revenue. And the data we were having was capturing the customer's life cycle and behavioral throughout the demographics like the age, gender, geography, and tenure, and then the financial stability of that particular customer, what is the credit score, balance, and estimated salary, and some intangibles such as like number of products that customer is using, as well as like the is that the customer is active or not. And ultimately, the goal was to find a proactive intervention in order to retain the customers within the bank. Okay. So the objective was to design a AI-powered churn prediction model, specifically on a neural network-based classifier that can anticipate the customers, which customers are likely to exit the bank in the next 6 months, so that proactive actions can be taken and we can, like the bank can minimize the financial loss and keep a strategic thinking. So the resource which I have used is proprietary data set which is coming from Kaggle. It contained 10,000 unique records of customers and had like around 14 different features, which included identifiers as well as predictive input features such as credit score, age, tenure, balance, as well as estimated salary, some of the geographical features. And at the end we had like the final target value which was excited, whether the customer is excited to stay within the bank or if they are not willing to stay, or there is a high possibility that they might change the bank. So this is like the data set on the number of like the columns which we had for the data set. So if you can see, right, there are some insignificant values such as row number, customer IDs, and surname. But then we have like important key factors such as credit score, geography, gender, age, tenure, balanced, unbalanced, and other details. And then at the end we had the target variable, which is excited, whether the customer would like to stay with us or not. So with this data set, we have done the same implementations, like we'll load the data set as well as like we'll perform the analysis on the data set, what information we are having, create like histographs as well as like box graphs, and understand what type of information is there, and then perform cleaning as well as deep diving on the training set, and then fine tuning our model. Uh, yeah. So this is again the same like data insight. Upon doing the data insights, I was able to figure out that there are no such data loss. The data was quite balanced, but in context of excited, there is around say 80% of the data, 80% of the customers are more likely to leave the bank in comparison to the 20% of the data which were planning to stay, as well as so this was the excited and non-excited like data which was present. And then we have the data representation in context of geographical manner, as well as like the gender and the number of products consumers are having. So we were able to figure out that there is a big number of consumers which are only having one or two products, which are only using one or two services of the bank, and like very few who are using all of them. And then there is the tenure of the people who like how long they have been staying with the bank, and like what's the number against that. Then we like try to I created a histograph and box graph for the credit score, as well as for the age part or the balance, and like estimated salary. One finding which we were able to see was that there is a very big number of people who are having a bank account but their balance is not good, and like that's kind of an insight which can be taken, right? So And then I also created this correlation graph, which was able to, which allowed me to check on the in context of excited, what parameters are more correlated to the like excited number. And the which based upon this correlation graph, I thought like we can check on the number of products and other correlation aspects as well. And when we did the graph out, that we were able to see that the customers who are having more products within the bank, who are using more services within the bank, are most likely to stay and are in excited state. Whereas if customers are having less number of what do we say products, right, then they are more likely to leave. Mm. So yeah, and the same goes with in context of balance as well. In context of high like excited and all, people who are having less balance are more likely to leave. Okay, so in context of data pre-processing, missing values treatment or feature engineering, removing unnecessary data or removing outlier part, right? What we have done is like we have used Smoot for few of the data models which we have run, but not for all the models. Feel like we have tried to go with few models without Smoot, and in like later on we introduce Smoot as well in order to see if the data like the response is improving or not. I'll share the findings later. And other than that, there were few features like row number or customer ID or surname, which were removed and data processing was done. So coming to the model building aspect, like I've gone with the FNN implementation, which is basically it's a basic yet powerful neural network where information moves sequentially from input to hidden layers to the output layer, right? So the data is usually going only in one direction and there is no feedback loop available. And like I've tried to use this FNN with different type of models approaches. So these are the like six different test case runs which I did with different models and different configurations. So we have gone with SGD. So stoic gradient descent was my base where I started checking on like what is the output we are getting in context of having an initial baseline, and we were able to see that the recall is coming around 0.66 0.666 around 66%, and the precision was also low, which is around 0.406. Uh, After that, the next model which we tried was ADM. ADM optimizer. So adaptive moment estimations, it improved the response in comparison to the SGD implementation, and we were able to see that the recall is improving and it has reached to 70%. But mostly when it was reaching to the end part, it was going towards more overfitting in the training set. That is where when the validation part was running, it was giving more error. So it was
Hi,
at the
Nirbhay, could you please wrap this up? We are out of time.
sure. Okay. So yeah, based upon this, so finally we were able to see that we give me a sec. Yeah, so in finally we were able to see that with ADM optimizer including with dropout, we were able to see the best outcome results. But when we incorporated Smooth, we were seeing some similar type of responses only with ADM and optimizer itself. But yeah, and then based upon the findings, we were able to see that we can uh, focus more on the elderly folks as well as uh, see if we can add more like more features for the teams who like for the people who are already having some services, as well as see how we can add the balance in the customers who are already there.
Uh,
Yeah.
quick question that you said that we should focus on the elderly folks. These feature importance is how did you extract from the deep neural network, the feed forward neural network?
This was mostly on the insight aspect, Sandeep, but based upon like not specifically from the data aspect, but from the factor and correlations, right? Uh, we were I
Okay. The
yeah.
one that you did in the beginning.
Hmm, yeah,
Okay. Okay. So basically, that's not based on the neural network. It's based on the initial data exploration.
correct.
Right. Right. So one more thing, that if you wanted to do like a interpretable, what I see that in the end you had like results to be interpretable. You are giving the recommendations and so on. In
Hmm,
such scenarios, what people usually do is they will go with simpler models. Like if you did, say for example, decision tree. Decision tree will give you the feature importance naturally. Similarly, logistic regression like the linear models, they will do that job very, I mean, they do a pretty good job. Okay. Yeah. All right. Yeah, that's pretty much. I think
okay.
this is good. All right. Thank you,
Thanks, Sandeep.
Nirbhay.